Carrie Roberts here, and in today's Atomic Spotlight, we're going to look at a tactic used by many groups. It's kind of a classic. It's in the defense evasion tactic, and here's an example that we have with Operation Wocao, or however you pronounce that. If we search through here for base 64, we see that under Enterprise Attack Technique T1027, obfuscated files or information, that this attack group threat actor executes PowerShell commands that are base 64 encoded. This technique is handy for defense evasion, which is why it falls under that tactic in MITRE ATT&CK. But it's also useful just from a developer perspective, because it makes it so developers or code writers or attackers don't have to worry about things like having quotes inside of quotes and having to escape those quotes. It just simplifies even execution. So it's really common, really popular. It's actually common and popular outside of attacks as well, which makes this harder to detect than otherwise would be, because there's a lot of legitimate use of this technique, but also used so much by malware that it's something that we do want to pay attention to. So let's click here on MITRE technique T1027 and jump over to there. Obfuscated files and information. There are 9 sub-techniques that break this down into more specific categories. For example, binary padding, software packing. We're not looking at any of those more specific sub-techniques today. What we're looking at just falls under the I call it the mother technique, or the main technique ID of T1027 without any sub-techniques. We have a tactic here of defense evasion, and it applies to all operating systems. Of course, if PowerShell core is installed on Linux or Mac, the same techniques can be used there. MITRE gives us a nice explanation here. It gives us some procedures examples, so different softwares that use this technique of obfuscation for defense evasion. We also have some mitigations listed here, which is, hey, use antivirus. That's maybe cheating as a mitigation suggestion here. Consider using AMSI, the anti-malware scan interface built into Windows 10, which is an excellent option, especially when attackers don't bypass AMSI, which is a topic for another day. And behavior prevention, so maybe using attack surface reduction rules, depending on if they're written for this commonly used technique. And here's some detection ideas. We won't look into those, but I just wanted to make sure you know that these are here in MITRE ATT&CK for you to look at, and more references to read here. So great resource here on MITRE ATT&CK. So to actually make this actionable and emulate this behavior, we're going to use the Atomic Red Team library of scripted cyber attacks. So I'm going to jump over to this tab where I have Atomic Red Team open. It's found under the Red Canary Co. company. Atomic Red Team, it's free and open source project with over 280 developers who have contributed. In here, we're going to look in the Atomics folder, because that's where the library resides. So let's click on Atomics, and in here we can find a folder for every technique number that has attack scripted in this library. So we take MITRE ATT&CK number T1027. And we see some of the sub-techniques, but we also see the parent technique of T1027. We're going to click on that to see what options we have there. And inside this folder, inside all of the MITRE technique folders, there's at least a YAML file, a markup language file, where the tests, atomic tests, are defined, and a markdown version of that YAML file that's a lot easier to read as a human. So we're going to click on this markdown version and get a nice table view of our atomics, T1027.md. Here we have a nice description copied in right from MITRE ATT&CK. So This is the same paragraph we saw over in MITRE ATT&CK, just copied in the top here. And then we have a list of atomic tests, 1 through 8. Today we're going to look at test number 2 and test number 3, executing base 64 encoded command with PowerShell. Really basic, but very powerful and very commonly used. And then we'll also execute base 64 using PowerShell, but we'll store the base 64 command in the Windows Registry, and then we'll read it out of the registry to execute it. This is commonly used by malware for persistence. So they store the code in the registry, read it out later, and execute it using that base 64 command, hoping to avoid detection by using encoding. Let's click on test number 2. And it says this is just a test that prints "Hey Atomic" to the screen. It's meant for Windows, which is what we're playing with today. And the command, here we have some inputs. We could change the command that this test runs. So by default, it's going to run right host "Hey Atomic." So just some PowerShell to print "Hey Atomic" to the screen. And then the attack commands, or the scripted cyber attack, is here. It's 5 lines. It's going to take this original command, the PowerShell command, which by default is that "Hey Atomic," and it's going to use PowerShell to encode it in base 64, which gives us our encoded command. This 4th line here, where it just says encoded command, we'll just make that encoded command show up on the screen so we can see what it looks like. And then this PowerShell -encoded command, and then giving it the encoded command is how you execute your encoded command with PowerShell. So very common malware technique here. We could copy and paste this command and put it in this variable syntax here of #squiggly, and then run these commands by hand within PowerShell to emulate this attack. But we're going to use the Invoke Atomic Red Team execution framework. It's a PowerShell tool that knows how to read this library of scripted cyber attacks and execute things for us. We're going to use it to make it easier for us. I already have that installed here. So we can use a command called Invoke Atomic Test. And we want to put in our technique number of T1027. And we'll say show details brief to just list the name of the test. We should recognize these tests from the list at the top of the markdown. Test number 1 isn't here. Test number 1 is a test that isn't supported on Windows, so it's not listed here since we're on Windows. So we have test 2 and 3 that we're interested in today. We're going to run. Let's blow this up a little. So now we can say we're interested in test number 2, and before we run it, we'll say show details, not the brief details, the full details, which is that same information we saw in the markdown file, just within our command line. Here we see those 5 commands we're going to run. It's got the input argument, the thing that we could change if we want as we run it, listed here in red, letting us know it's a configurable variable as we run this. And then here's another version of those same 5 commands with the default value put in. So it's going to run the command right host "Hey Atomic." So at this point we could copy these 5 lines and paste them right in here and run it, or we can just tell the Invoke Atomic Red Team framework to run it for us. We get rid of the show details and run the test. And now it's base 64 encoding our command, which we see here. This is base 64 encoded version of right host "Hey Atomic." And then you see the output where it actually executes the command, which is this last line where it's executing the command. And then we get some progress output in XML format, which we can ignore. So that's super easy. At this point, we might go into our defensive telemetry to see if anything alerted on this, or to see if it stands out as unusual, so maybe something we can detect in our environment. Now let's move on to version number 2 of the attack emulation, which was test number 3, show details. This version writes the base64 encoded PowerShell to the registry. So we've got the commands here, and the input arguments are in red, so we can control as we run this the PowerShell command to run, the registry key and key name, where we want to store the base64. And then we also have an easier to read version of the commands with the default values put in. So here we have write hey atomic here, and then the default location that we're going to save the registry is in HKCU, which is Hive key current user, software, Microsoft Windows current version. And we're going to store our base64 coded command in a key called debug with the value of whatever our encoded command is. And then when we execute it, we'll say, hey, PowerShell, execute this command, which says invoke expression, which is what we use when we want to use a string value as a command. And then we say, hey, invoke the string, and we read the string, get string, out of the registry, which we do with get property. This is an alias, a shortcut to get property. So we're getting the property of the HKCU registry key called debug, and then we're base64 decoding it and executing with invoke expression. Also a very common malware technique. This atomic has some cleanup commands, so you can imagine we're throwing some random base64 encoded PowerShell into our registry, and we might want to clean up our system afterwards. So this will remove that property from the registry key, as shown here, current version debug. It's going to erase that for us. So now running it is just as easy as taking off the show details option. We run that, we'll see hey atomic printed to the screen. We could also say get item property, and we could paste this in. And here we see our base64 encoded values stored in the debug key, and that matches this. And this would typically be used in persistence. Now, just to make this a complete example, let's say we wanted to use a different command, something more realistic than just writing hey atomic to the screen. So let's clear the screen. In this case, we can add in a prompt for input args to the end, and now it prompts us for each of the input arguments. So what registry key do we want to store it in? Let's just press enter to accept that default. What command do we want to run? So this is where we could configure it to run something more realistic. In this case, let's just do add content to the users art test.txt, and we'll add base64 or 65. That'd be cool too. Base64 example, and the key name of debug is fine. Let's run that. Here we have a different value than we used to have. Let's see if we have a file called test.txt here and print it to the screen. Base64 examples. So we just customized our execution of this atomic to make it fit our environment better, perhaps, or to be more realistic. Maybe we want to store it under a different key to more accurately reflect an adversary that we're trying to emulate. So that's what I have for the atomic spotlight today. We showed you a quick overview of MITRE ATT&CK and how that gives us the background on adversary behaviors being seen in the wild today. And then we take that over and cross-reference that into our atomic red team library scripted cyber attacks using the MITRE technique number. We find tests that we're interested in, and we can easily emulate those behaviors using the Invoke Atomic Red Team execution framework. If you're interested in learning more about all things attack emulation, including Atomic Red Team, Prelude Operator, and MITRE Caldera, check out my class on Antisyphon Training.